Alrighty, here we go. First video of the season of the year of 2025. Let's see how it goes. I had to take off early, had to take James to the doctor today. Okay, so we will talk about weekends tomorrow in class. All right, I'll ask you about your weekends, and I'll tell you about mine. All right, sound good? What I'd like you to do is I'd like you to take out your note packets that we've been using, your Chapter 7 note packets, and flip to page 7. Okay, flip to page 7. All right, it looks like this. We're going to do numbers 1, 2, and 3 as our warm-up today. So what I would suggest doing is try the problems first. Okay, try them first. All right, maybe give it a shot. You know, maybe take a little pause the video, if you will, and then give numbers 1, 2, and 3 a shot. Okay. Use your packets to help you. You can use your quadrilateral packet to help you as well on this. All right, but give it a pause. Try it yourself first, and then come back and watch it. I've had success with that in the past, so let's see how that goes. I'm sure some of you haven't paused yet. So if you were thinking about pausing, maybe pause. How about a pause? Let's pause. And as we stop pausing, remember the first thing you should do is label your picture. So I know that this angle WIR is x plus 4. This angle right here, TIN, is 3x minus 8. All right, and then this whole W to N is 2x minus 1. All right, this angle, okay, this entire angle in a rectangle, that entire angle is a right angle. I don't know for sure that x plus 4 is equal to 3x minus 8, so I can't set them equal. But I know for sure that those two angles are complementary. So I can take the x plus 4 and the 3x minus 8, not minus 3 minus 8, and set it equal to 90. Okay, because they're complementary means they form a right angle, which means it's 90 degrees. You do get a decimal, and that's okay. Decimals are numbers. I believe you get 23.5. So if you're doing 4x minus 4 equals 90, 4x equals 90, 4x equals 23.5. Now the question asks you to find T to R. Well, remember, in a rectangle, the diagonals are, these diagonals are congruent, all right? And they are bisected. So if I know what WN is, I can find WN by plugging my x value in. So 2 times 23.5, which is what? 2 times 23.5, which is what? 47? That should be a plus 1. There you go. 47 plus 1 gives me 48. So T to R must be not 48, but 48 divided by 2 to get 24. Okay, because it's half. T to I is 48. T to R is half that value. All right. All right, let's try number 2. If you haven't stop the video now, flip to the square. Okay, first thing I would do is label the picture. This is a doozy, but it's fun. Okay. First question asks you to find DEC. I don't even need to do any math to find DEC because all 4 of these angles right here, our diagonals, are perpendicular. So that's 90 degrees. I do need to do some math to find the perimeter. All right, I can do this 2 ways. First of all, remember the square is a super shape, which means not only is this a right angle here, but it's split into 2 equal parts. Okay, so I can set this up 2 different ways. I could say, all right, well, if it's 2 equal parts, then 2 times this whole thing is equal to 90 degrees. Or I could say x squared, holy buckets, x squared minus 4x equals 45. And then do some factoring. Bring that 45 to the other side and say x minus 9. 2 numbers that multiply to 45 and add to negative 4. X minus 9 and x plus 5. So I get negative 5 and positive 9. Remember now, a lot of us are going to throw out the negative. okay? But you have to plug the negative x value back in. I have to see if it works because there are going to be times where that negative x value will work and the positive one won't. Does that mean? Potentially a little cruel, all right? But that's just math. You know, math can be mean sometimes, right? I guess so. Okay, wow. All right, so if we plug in -5, this actually doesn't work. So all that for nothing. It's actually 9. X is 9. If I plug in 9 here, I get 9 minus 1, I get 8. Hey, remember, this is the super shape, so all the sides are the same. So the perimeter is 8 times 4, which is 32. Isn't that neat? That's pretty neat. Wow. Last one, okay? Some people get stuck on this ratio stuff, all right? Remember, in this class, it's a ratio of angles, all right? The angles are in a ratio, the sides are in a ratio, whatever it may be. Put an x, 2x, 6x. Those two angles together, 2x plus 6x, has to equal 180. They're supplementary, so 8x is 180. So I believe you get 22.5. Remember, decimals are okay. But it asks you to find the measure of angle A. All right, in order to do that, well, the measure of angle A is equal to the measure of angle K. So I just do 6 times 22.5. If you have any questions, make sure to write them down, all right? Or mark them or something, and we will talk about them. You can ask me tomorrow in class. All right, we're fast forwarding through the cat, remember? All right, and we're going to go to this. Okay, the coordinate proofs. Now, I know what you're thinking. Proofs, holy cow, those are back. To a certain extent, yes, but not in the same way that you did first semester. All right, in a different way this semester. Coordinate proofs are just plotting points in a coordinate plane, okay, and then finding the slopes of the sides. All right, you can use a distance formula as well, but it's easier to find the slopes of the sides. It makes more sense in my head to do it that way, and I found that it makes more sense than a lot of other people's heads as well. Okay, so all we're doing is we're going to plot these points. Be careful. Remember, each point is x comma y. All right, so x comma y. This is the x and this is the y. So I got 1, 5, 6, 5, 6, 10, and 110, and it's A, B, C, and D, and connect my points. So anytime you do one of these types of problems, you will find the slopes of all 4 sides, and you'll find the slopes of the diagonals. That's what you'll be finding. So that's 6 slopes, okay? 6 slopes. Remember, your diagonals go right through the middle of the shape. All right, you'll find the slope 6 times. Now, here's the deal, though. Okay, because we gave you this nice coordinate plane, you don't have to use the slope formula. You can just count rise over run. You don't have to do y2 minus y1 over x2 minus x1. Just count. It'll make your life a lot easier, save you a ton of time. Okay? So I need to find the slope of AB. I need to find the slope of BC, CD, and DA. Now, I did that order on purpose, okay? Because remember how we label a parallelogram? We go around in a circle like that, okay? That's, what is that, counterclockwise? Counterclockwise? Yeah, counter. I'm looking at the clock. Yeah, counterclockwise, okay? I want to stay consistent with not only how I label it, but how I find the slopes. So I'm going to go counterclockwise, all right? Because if I go AB and then decide to go CB, it's just going to be, my answers might be a little bit different, and it's going to be a little bit more difficult, okay? AC and then DB as well. So again, that's 6 slopes, 6 slopes. If I find the slope from A to B, try it if you want to try it first. A to B, I don't go up, I go up. I don't go up or down at all, so it's 0, and then I go to the right 5. From B to C, I go up 5 and over 0. From C to D, I go up 0 and left, so -5. And D to A, I go down 5 and right 0. Right or left 0. All right, so remember, 0 over any number is just 0. Is just 0. If you try to plug this into your calculator, 5 divided by 0, you'll get an error message, which makes this undefined. It makes this undefined. We'll talk about the relationship in a second. A to C, the slope from A to C is what? Up 5, right 5. And D to B, down 5, right 5. Okay. Well, let's go back to the slopes of these sides. You notice that number one, first of all, these are the same, and these are the same. Yellow, these pairs of sides, so A, B, and C, D, and B, C, and D, A, those are opposite sides. And if two lines have the same slopes, those opposite sides, or those lines are parallel. So our opposite sides are parallel. Our adjacent sides, remember adjacent means right next to. So our sides that are right next to each other, so if I'm comparing these two, and then these two like that, those have opposite reciprocal slopes, so those are perpendicular. Remember, opposite reciprocal is like 3/4 compared to -4/3. All right, those are opposite reciprocals. So those are perpendicular. Our diagonals are also opposite reciprocals. So these are also perpendicular. So this shape, all three things are true, meaning all three things are positive. The opposite sides are parallel, the adjacent sides are perpendicular, and the diagonals are perpendicular. So it's our super shape, which makes this a square. All right, these are the three things that I'm about to highlight in yellow. You should always have not only all your slopes, but you should make a comment about the opposite sides, the adjacent sides, and the diagonals. All right. You should make that every single time you do one of these problems. You'll find 6 slopes and then compare these 3 things. Okay? I want you to plot this is one you're going to do on your own. We're going to go over it tomorrow. So I'm going to plot this for you, okay, so you can make sure you're doing that correctly. All right, and then we will go over this problem at the beginning of class tomorrow, as well as some more of these. I'd like you to work on this one for tomorrow at the beginning of class. There are big ideas assignments. There is not one over this section. All right, but there are 3 from last week. And then you will also find A to C and D to B. Okay, so find all those slopes, and then you will make a comment about the opposite sides, the adjacent sides, and the diagonals. All right? All right. We'll see you tomorrow.